Dear students, in this in this lecture, we are going to see about Schrödinger wave equation. The last lecture we have seen the introduction of quantum mechanics and that photoelectric effect and its characteristics, and also de Broglie wavelength. So today's class we are going to see the Schrödinger wave equation. Okay. So what is Schrödinger wave equation? Schrödinger wave equation is nothing but equation is a mathematical equation to describe the wave nature of the particle. Okay. Earlier we have seen that photoelectric is a particle nature, and de Broglie is that waves like waves how behaves like a particle. Similarly particle behaves like a wave. So in order to explain that particle nature of the wave nature of the particle, the Schrödinger had developed a theory to explain the wave nature of the particle. Okay, so there are two forms of Schrödinger wave equations are there, that is time independent wave equation, then time dependent wave equation. So he derived the equations, Schrödinger's wave equation. He derived two equations by incorporating by two assumptions. So first assumption is, so we know the total energy is kinetic energy plus potential energy, right? Kinetic energy plus potential energy. We know the potential energy is V, kinetic energy is half mv square. So this is equal to V plus 1 by 2m is multiply with the term and divide by m. That will not change the equation. V plus 1 by 2m into m square V square. This will give you is equal to V plus P square by, this one is P, right? mv is the momentum, P square by 2m. So it will give you 2mv plus p square by 2m. So bring this term this left side, you will get 2m capital E is equal to 2m v plus p square. So now this p square is equal to 2m E minus 2m capital V. So the momentum can be written as P is equal to square root of 2m into E minus V in terms of energy, kinetic energy, potential. This is very important. So in terms of energy, the momentum can be written as P is equal to square root of 2m E minus V. So we know momentum P is equal to h by lambda. So from this, lambda can be written as lambda is equal to h by square root of 2m into E minus V, right? The another assumption is that, second assumption, the wave function associated with the matter particles with the function of time t is given by psi is equal to psi naught into e to the power minus I omega t. So here our psi naught is amplitude of the wave at a point x, y, z. So omega is frequency, it is given by 2 phi nu. So based on these two assumptions, means lambda is equal in terms of potential energy and kinetic energy, total energy and potential energy, we give a lambda is equal to h by square root of 2m into E minus V, and this assumption of wave function, we are going to derive the two equations, time dependent and time independent. So for the time dependent Schrödinger equation, consider a system of wave associated with the moving particle. Okay, let psi be the wave function of the particle along x, y, z coordinate at any time t. Okay, so that's what we are saying. It's a wave function of a particle which is moving along xy coordinates at any time. It can move at any coordinate, it is given by at any time t. Okay, so differential wave equation of a progressive wave with wave velocity u in terms of Cartesian coordinates, we can written as d square psi by dx square plus d square psi by dy square plus d square psi by dz square is equal to 1 by u square d square psi by dt square. This is the wave equation that you have already studied in the lower classes, that with wave velocity. Okay, this is already derived equation. Okay, so the solution of this equation is given by psi is equal to psi naught e to the power minus I omega. So x, y, z is nothing but is the dimension, 3 dimensional. Okay, so psi is the wave function, wave, whenever the particle moves it has the wave nature, so that is expressed by in the psi, right, wave function. U is the velocity of the particle moving with wave velocity. So you know the psi is equal to psi naught e to the power minus I omega t. So you have to differentiate, right? We are having that differentiating this equation with respect to t twice. So first we have to differentiate with respect to t, d psi by dt is equal to with respect to time, right? So this I omega psi naught into e to the power minus I omega t. Then once again with respect to t we derive differentiate d square psi by dt square is equal to minus I omega into minus I omega psi naught of e to the power minus I omega t. So this d square psi by dt square is equal to I square omega square psi naught e to the power minus m. We know the I square is minus 1, right? So d square psi by dt square is equal to minus omega square. This is nothing but psi, right? Psi is equal to psi naught into e to the power minus I omega t. So minus omega square into psi. So now substitute in this v equation. So d square psi by dx square plus d square psi by dy square plus d square psi by dz square is equal to minus omega square by u square into psi. So we know d square psi by dt square is equal to, we have derived minus omega square into psi, right? So this we have to substitute here. Instead of d square psi by dt square is omega square by u square into psi. So d square psi by dx square plus d square psi by dy square plus d square psi by dz square is equal to minus omega, we know, right? Angular frequency, it's equal to 2 phi nu, right? This is angular frequency. So it can be 2 pi omega, sorry, 2 pi nu the whole square by u square into psi. So we will get d square psi by dx square plus d square psi by u square plus d square psi by dz square is equal to 4 pi square nu square by u square into psi. So this is minus 4 pi square nu square by nu square into lambda square. Nu is nothing but velocity, right? Velocity, you can write c is equal to nu lambda, right? Similarly, the wave velocity is given by that, you can write c square is equal to nu square into lambda square. So the d square psi by dx square plus d square psi by dy square plus d square psi by dz square is equal to minus 4 pi square. This nu square will get cancel, lambda square into psi. So we know that first assumption, the lambda can be written as in terms of total energy and potential energy. Lambda is equal to h by square root of 2m e minus v, right? So d square psi by dx square plus d square psi by dy square plus d square psi by dz square is equal to minus 4 pi square lambda square into 2, I mean lambda, in terms of lambda you are writing lambda square is equal to h square 2, it will get cancelled, right? Square, so 2m into e minus v the whole side. So this is nothing but d square by dx square plus d square. So operator, this operator is called Laplacian operator. So d square psi by x square plus d square psi by d square plus d square psi by dz square is equal to minus 4 pi square h square 2m into e minus v into psi, right? So you simplify that, you will get substitute del square here instead of d square. For this you get d square psi is equal to minus 8 pi square h square m into e minus v into psi. So here we are going to introduce another term called reduced Planck's constant, that is h bar, okay, is equal to h by 2 pi. This means h is equal to h bar into 2 pi. So h is square, it is there, so h square means h bar square into 4 pi square, right? So del square psi is equal to minus 8 pi square h bar square 4 pi square m into e minus v. So del square psi is equal to minus, this will get 2m by h bar square e minus v into psi. So finally we get del square psi plus 2m by h bar square e minus v psi is equal to 0. So this is Schrödinger time independent wave equation, okay, del square psi plus 2m by h bar square e minus v into, this is total energy of the system, total energy, this is potential energy. In terms of potential energy and total energy, you can write the, this is psi is wave function, right? So next one is the time dependent wave equation. So the second assumption, psi is equal to psi naught e to the power minus I mean that assumptions what we get in the previous slides. We have shown that wave function. Similarly, we are also derived that equation from the same wave equation. D psi by dt is equal to differentiate this wave equation with respect to time, you will get minus I omega psi naught into, so this will give minus I omega psi, so this will give a minus I 2 pi omega is nothing but 2 pi nu into psi, right? So here we are introducing E is equal to h nu, from here nu is equal to E by h, so that value you are substituting here, minus I 2 pi into E by h into psi. Similarly, like that earlier I am skipping some steps, so finally we can similarly we know the time independent equation, from there you can substitute this value, energy value, we have derived an equation. So this I have skipped many steps, so finally I just want to show that Schrödinger time dependent equation can be derived like time independent Schrödinger equation in terms of Hamiltonian, so that I will tell you what is Hamiltonian in the next slide. So I h bar d psi by dt is equal to minus h bar by 2m del square psi plus v psi. This is the Schrödinger time dependent wave equation. So we know that del square is Laplacian operator. So this equation Schrödinger time dependent wave equation we mean by h psi by is equal to E psi. So h psi is nothing Hamiltonian operator, that is h equal to minus h bar square by 2m into del square plus v. Okay, and the energy operator is equal to I h bar d by dt. So this is the energy operator. So next, wave function. So what is the properties of wave function? A variable quantity. So physical significance of wave function. But first I want to tell what is wave function. We have already derived that wave function which describes the characteristic de Broglie waves is known as the wave function and is denoted by psi, right? So the value of the wave function associated with the move particle at that coordinate x, y, z and time gives the probability of finding the particle at the time at that point. So what is the physical significance of wave function? The wave function has actually no physical meaning. So it is a complex quantity representing the matter wave of the particle. For example, psi square is there, but however psi is a, you can see that psi is a imaginary, right? Psi naught into e to the power minus I omega t. However, if you the probability is, if you multiply the psi with the psi, we will get the psi square, right? So mod of psi square is a real and positive, so the amplitude may be positive or negative, but the intensity, the square of amplitude is always real and positive. So psi is not, the wave function has no physical meaning. Psi doesn't have any meaning, but psi square have physical meaning. Okay, psi square represents the probability density or probability of finding the particle in a given region. So this is the probability of psi square will give you the probability of finding the particle at particular time. So for a given time, the probability lies between always 0 and 1. So that is given by p is equal to integral of psi square d tau. D tau is the volume. So the probability lies between 0 and 1. So psi square d tau is equal to 1. This function is called normalized wave function. So the psi, this is the very important thing. So the physical meaning is have that psi wave function doesn't have any physical meaning, but psi square is having the physical meaning, and it gives the probability of finding the particle in the given region. So up to this we will complete today's lecture. In the next lecture we will see about the applications of Schrödinger wave equation. Thank you.